Hi students, welcome you all to the introductory class for our new course for this upcoming semester, Creep, Fatigue and Fracture for 7th semester BTech degree in Metallurgical and Materials Engineering. So this video is basically intended to provide you with a very brief idea regarding this particular course and what are the main concepts we will be dealing with in this particular course for this semester. And basically three, as you know, you have 6 modules to be completed this semester, and 2 of the modules will be dealing with the subject of creep, 2 of the modules will be dealing with the subject of fatigue, and the remaining 2 will be dealing with the subject of fracture. So before going into the details of this subject, I would just I just want you to think of what is meant by creep, what is meant by fatigue, and what is meant by fracture. So many of these things you have already discussed or you have already studied in the courses on mechanical behavior and testing. So I hope this will be like a cakewalk for you, and you will be finding this course as very interesting because the practical applications of creep, fatigue as well as fracture will be discussed in detail in this particular course. So I would just like to start with the showing with some of the slides that will help you to gain a in-depth knowledge on these concepts. So going into that, I just want you to think of the concept behind creep. So before going into creep, I just want you to think of 2 real-time examples. A very basic example we can start with. Suppose you are holding your hand in a perfectly straight direction like you used to do in the morning assemblies in schools. So say for example you are telling India is my country. So in like that, in that position, if you are holding your hand for a particular period of time, you will not be feeling any kind of pain in your hands. But the same posture, if you are continuing for say for example 1 hour or 2 hour or 3 hour, with passage of time your hands will start feeling this pain, and gradually you will be forced to push down your hand, and ultimately it will come back to the bottom position. Okay, why is this so? So initially you were keeping like this, so with passage of time it came down, it came down, came down and came down. So there is something like a deformation which is occurring to your particular hand, but which is a function of time. This is what you mean by the concept of creep. So creep is nothing but the time dependent plastic deformation of a material because of the application of a continuous load or a continuous stress. And I will give you another beautiful example. Consider the overhead transmission lines that is used for taking away the electricity or supplying electricity to different places. So at the time of installation, you can see that these particular transmission lines will be perfectly straight and there will not be any kind of a deformation you can observe in them. But with passage of time, you can say that initially the transmission lines which were like this perfectly straight now starts to bend, and now it becomes something like a U shape. So this is what you mean by, or you call by the term sagging. And this sagging occurs again due to creep because of the weight of this particular wires which is acting down. So with passage of time, ultimately this load acts in the downward direction and it makes this transmission line to become bent. So with this preliminary idea, we will see what is meant by the definition. We will go to the definition of creep. We will see what are the various tests that are available for measuring the creep behavior of a material. What are the various stages of the particular creep curve, which you call by the term classical creep curve. Then the metallurgical factors that are influencing the different stages of creep behavior, and what particular effect stress and temperature has on the creep rate. Then the very famous stress rupture test, which is a very rapid test that is used to determine the rupture behavior or the service life of a material which is subjected to this kind of a particular high amount of stress. Then the Mongman Grand relationship, which is very important, and then how to determine the creep life of a material, and then some very basics of testing as well as the fracture phenomenon occurring at high temperatures. So this will be the basic things or the basic idea you will be gaining after completing this particular module. So in the next video, we will go in depth regarding all these things. And before winding up, I just want you to think of what is meant by fatigue as well as fracture. So fatigue is again, it is another type of a deformation which is occurring in materials because of the application of a continuous or a cyclic loading. The very simple example for fatigue is shafts that are used in automobiles as well as gears for power transmission. So all these things, it will be under these kind of particular, what you say, the shafts, they will be undergoing fluctuations in this their load, which you call by the term cyclic loading. And because of the cyclic loading, it undergoes failures. And that you, what do you mean by the phenomenon of fatigue? This fatigue can in fact happen to we human beings also. You normally say that after walking for some time or taking some kind of load on your head and you are walking, after some time you feel tired. You say that you have reached your fatigue limit. So likewise, materials also have a particular kind of a saturation limit, and beyond that limit, if the stress is applied, they will also start to behave in a different way, which is manifested or which is called by the term fatigue. Finally, to say about fracture, it is the ultimate failure of a material, and that you call as fracture. So the very simple example for fracture is take a glass on your hand. You know that glass is a very brittle material. This glass you just drop from your hand. You can see that this glass breaks into pieces. The same thing if you do on a piece of aluminum. If you are putting it down, it's not going to fracture because the force that is required to break that glass was very less, so that it just from your hand, when you drop it, it will fracture or it will get broken into different pieces. So there comes the concept of ductile materials and brittle materials. So the difference between ductile materials will undergo a ductile fracture and brittle materials will undergo brittle fracture. And the difference between brittle fracture and ductile fracture is that brittle fracture will not give you any kind of indication that the material is going to fail. It fails all of a sudden. Whereas in the case of ductile material, you get an indication regarding the failure of that particular material. So that is a special case regarding the two types of fracture, which we will be dealing in depth in the upcoming classes. So for the time being, I just want all of you to think of this particular phenomenon of creep, fatigue as well as fracture, and what influence it can have on the behavior of a material. So wishing all of you a very good day ahead, and we will meet for the next class in the upcoming week. So wishing you a very successful course ahead in this particular course on creep, fatigue, and fracture. Thank you.